Okay, perfect. Yeah, now tell, you had some question, right, pertaining to the last session. We can discuss that first.
Yes, yes. So in that linear regression, are there only these three algorithms, linear regression, last, and reach, or are there any others?
Okay. Okay, I think
And
I should address this problem first. Let me see. I'll just show you one thing first. Okay, now you see the screen. So if you see here, this is your linear regression. Then there is polynomial and regularization. Then logistic, decision trees, random forest, bagging boosting. Forget bagging boosting. KNN, knife based SVM. Okay, K means, and rest of it is okay. So these each of these are models. Okay, these are different models. So for example, as I have told you that when that God function we are not able to figure out, right? So how to go to that God function? We are trying different models to go to that God function. Now, when I introduce linear regression is a single model. Okay. Now, for example, you have think from the starting. Okay, so these models are basically maths and statistics, right? So, for example, you made a model. Now, I came up with this idea ki, I think if I add the regularization part, the accuracies will be better. Okay. Now, there's some other person comes and says that, okay, no, I think if I add this type of regularization, mathematically, he is a better guy in understanding mathematics. So he says, I think if you add this kind of regularization, that will be much better. So like this, we had some tweaks in linear regression. Linear regression is basically where your function is equal to y into y equal to a plus beta x plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. This is your linear regression. Now, how to get to this b? There are certain ways. Okay, so certain ways is you can reduce the RMSE, or you can have RMSE and a regularization part. So there are various ways where you can reduce the RMSE. But linear regression as such is a single model. Okay, so for example, we'll go into different models today and understand, what other models, why do we have other models. But so for example, there's something called elastic net. Okay, I'll just show you elastic net regression. Okay, now just see this. I'll show you the elastic regression. See, what we saw last time, if you see here, ridge was when we had this and this. Okay, lasso was when we had this and this. But elastic net is something which combines all these together. You have you have the regularization of a linear. I think there's some disturbance in the line. I'll just mute everyone. Okay. So elastic net is something which combines the regularization of both. Okay. So for example, you have a ridge and a lasso together combined in a elastic net. So now you won't say that elastic net is a third type of linear regression. It is not the third type of linear. Your basic equation, of let me open the pen. I'll just write down your basic equation of y is equal to a plus beta 1 x1 plus dot 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 dot. Okay, this always remain constant. This is a linear regression model. Okay, So whether I do a ridge, whether do I do a lasso, whether I do elastic net, it doesn't bother. I mean, it doesn't bother. This equation will always be remaining same. This is a regression problem. Okay. I mean, this is a linear regression thing. Now, how to achieve these beta 1? There are certain techniques. So for example, I can directly reduce the RMSE, or if I can combine to a regularization part and reduce the RMSE, that also can be done. But your linear regression is this form. Okay, so I'll just unmute. Now you can ask whether tell me if it is clear or not.
No, sure. This linear equation, that's very clear to me.
Yeah.
My question is actually three models. Now this time fourth model, I'm learning one linear, plane linear, which is in scalar, lasso and reach. Now this elastic net. Now I have four linear models. So are there any other linear model or not? That is the first question.
Okay. No. So as far as the domains are concerned, you can have a single regularization, double squared regularization, or a combined. So these are the kind of three models that can be used to derive the linear regression model. Okay, this is your answer to the first question. Now, what's your next question?
Okay, so on that day we saw that there was something, some X list was given, Y list was given. 0, 1, 2, 3, and 1, 3, 5, and 13. Then we replaced 11 or 13 by 200 to show us outlier.
Correct.
So that is one part. Now I understand the outlier. But while coming on this Boston data set, which has 13 fields,
yeah,
one field, when I was going some tutorial, it was showing that crime that was very accumulated at a particular pace. So they adjusted it using log methods basically.
Okay.
And after that, they went to see how other 13 are related. Okay, before 13, he was showing that how you go and see which fields are not affecting much, so we can remove that. As like last, so by default remove some fields.
Correct.
I remember.
Correct.
So it was showing manually one by one step that now you have to go price versus every field one by one.
Yeah.
See whether that is affecting much or not. If not, remove that. In that way, it was going one by one. Then finally selected 4 or 5 fields. But for one field ratio, it was accumulated, so it adjusted using the log methods. So, and after that, it draw mean, median, everything. But still, after that, I found that the square mean variation that was around 28, 29. So my question is, was this end to end, or is there anything to do? Because this is one of the example I want to understand end to end.
Okay, I got it. So I think that's a good question on how you have an end-to-end problem. So that's what I would suggest is, first let us go through the models. You just have a flavor of the models. When the project will come now, we'll have everything end-to-end, and because linear regression is not the end state, right? You have not just fit the linear regression, it closes. What we will do when we have the project work in, I think the last but not the least week, second last week, we have a project work where we have an end-to-end solution, and where I'll show you how you approach the problem, because every data set, if I go end-to-end, then there will be a lot of time occupied and will not be able to see all the models. So first, let us understand each of the basics of the models, and then when we do our project work, we will see everything end-to-end, how to approach, how to remove the outliers, how to see the data, everything. So what I have told you right now is that you have a data set. This is only the third way, right? So if I tell everything all together, that you need to find the correlation, and then you find fit the model, and then you do this cross validation, this, everything will get confused. So I will touch everything, whatever you have told me. It's good that you are doing your homework and coming up with very good questions. That is good, but understand this thing, because linear regression is not the end. Then there will be again this end-to-end process is not complete. Then there will be another model. Then will be another model. So once we get into all the models, then because what you're trying to say is that you're manually seeing each of the variable and its effect on this thing. So when I go to decision trees and random forest, I'll explain you tomorrow. Random forest will go into that. There is something called a Baruta plot, and it will easily give you the importance of that. You don't have to go, because you don't have to go manually into that, because when you have 100 features or 1,000 features or 1 lakh features, it is not practically possible for you to go manually and see each of the relation, right? And then again, each of the relation does not mean that the so for example, there this is your response variable, okay, and then there is something called x1 as a feature, and then there is something called x2 as a feature. So now you see how x1 and y is related, okay. Now you see that this relation is very good. Then you test how y and x2 is related. You see this relation is very bad, but and then you remove this, but that is not the correct way, because your model is y is equal to x1 plus x2. This you have designed a linear model there. The actual function may be x1 plus x2 into x1, and that's why when you just put x1 x2 and you do not consider x1, it becomes irrelevant. But when you combine this factor with x1, it becomes highly important. That also happens. So that's why I've not completed an end-to-end thing in terms of a linear model.
Okay.
Yeah, got it. We'll come to that when we do the
Yeah, I got it.
everything accordingly.
Sure. Thanks a lot. I will wait.
Yeah, sure, no problem. Okay. Anyone has any other question? No. Okay, then we'll start with today's session. Okay, I'll put you guys on mute. Now, so today what we will do is we are going to have a KNN revisit. Okay, and also last time you was asking how to you achieve your how to do your cross validation and achieve your hyperparameters, and you achieve the best K out of KNN. That also we'll see today. Okay, so let's yeah, Sunil, we will do K-neighbor today again. Okay, don't worry. So just just to refresh the idea a little bit, what are the three prerequisites of ML? Basically, a pattern should exist. A data should have something behind going on behind it. It should not be a random process. I mean, it should not be a completely random process. If it is a completely random process, then you cannot apply machine learning and find out the predictions. Or you could say your predictions will be very bad. The mathematical model should be unknown. If you already know the God's function, you need not find the need not use machine learning to tune. And there should be a lot of data. Sometimes the data part is little constrained. You'll always not find a lot of data. Sometimes there are also techniques, how to add a little more data, or how to go around the cases where you don't have proper data. Okay, so we'll see all that thing eventually, but let's start with a little bit of revision of what we. So I'll not repeat all these things. Okay, so let's start with nearest neighbor classification. Okay, I'll open a notepad. Okay, I mean, let's open. Okay, now if you go to this part where we see here. Okay, I'll use this on this pen. So if you remember, what we did last time is you have certain okay, now let me open the notepad first. So for example, your data is your data for example is weight of the bird, okay, then a number of legs, okay, and then let's say feathers, whether it has feathers or not. Feathers almost every, I think we don't need this. Feathers everyone has. Let's say, does it have a sharp beak? Beak is sharp or not? Okay, sharp or not sharp, something like that. These you have features, and then what you have to do is you have a lot of data. Let's say you have 100 data points, or let's say 1,000 data points. You have collected, you know, 10,000 data points for different birds, and now what you're trying to do is you wanna someone is going to tell you all these features: weight, legs, whether it has beak and not, and it can be anything, right? So you want to predict whether that is a chicken, that is a, it's a duck, whether it's a swan. I mean, I don't know the difference between these. Let's say this is a chicken. Okay, this is a duck. This is a swan. Let's say this is a black duck, a little different species of duck. Okay, I'm just terming it here. And let's say this is a baby chicken. Okay, so now you're given the data. You need to find out what is the let's say what is the uh, type of bird that your test is. Okay, now very important measure. I mean, now let's say when you're trying to calculate the distance, you have to define a measure that you want to keep, as a distance measure. For example, if I want to measure how far is Mumbai from Pune, I would say that is 500 kilometers, or sorry, 150 kilometers. It is around 150 kilometers. So you need to have a distance measure. So similarly, if I say how far is Delhi from Bombay, it is around 1400 kilometers. Okay, so there's a distance. So if I say, are Pune people more similar to Mumbai, or Delhi people more similar to Mumbai? Okay. So based on the distance, you could say, I think Pune is more similar to Mumbai. If you just consider, because a lot of Marathi people live in Mumbai, they travel to Pune. So if at a particular snapshot, if I say how Pune people are similar to Mumbai. So I would say a lot of Mumbai people would be in Pune. So I would say, because the distance is less, there's high chance of people flocking to Pune than to Delhi. Okay, so based on this distance measure, I would say, I think Pune, since it is geographically closer to Pune, I think Pune people are more similar to Mumbai people rather than Delhi people. So this is some distance measure you know that it exists. Okay. Now there can be a distance measure also. For example, how many number of Marathis are there in let's say Bombay, and the number of Marathis. Marathi is basically a kind of a regional language, regional. Uh, I mean, kind of what is the language that Mumbai people speak. Okay, so if I say what are the number of Marathis in Mumbai, does everyone understand this context? Because I mean, guys, I don't know the background. You have been living in US so many. I mean, from your birth, or I don't know. So everyone understands this context, Marathis and all. Right? Okay, I think everyone understands. That's good. So if I say, give me the number of Marathis or the percentage of Marathis in Mumbai. Okay, so you say the percentage of Marathis in Mumbai is, let's say, 95%. The percentage of Marathis in Pune is, let's say, 70%, and the percentage of Marathis in Delhi is, let's say, 20%. Now, on the base of this, also you can have a distance measure. Okay, so what is the distance between Pune and Delhi in terms of the Marathi people distance? It's about, let's say, 95% minus 25%, so it's around 75%. Or if you put in maths, that's it like 0.75, and put it in numbers, it's 0.75. Similarly, what is the distance between Mumbai and Pune in terms of number of Marathi? So we said it's 0.95 minus zero point 0.7, so that is 0.25. So if I add two features, let's say distance in kilometers and the number of let's say Marathis as in percentages. These are the two features, and I want to say whether Mumbai is more similar to Pune or Delhi is similar to Mumbai. You get the essence, right? So what you try to do, you had features, you kind of, I mean, formulated what is the distance between the features of each of these cities, and then you have say that since Mumbai is closer to Pune or Pune is closer to Mumbai, Pune people are more similar to Mumbai other than Delhi. So you can have any number of features like this. Okay, let's just hold on for 1 minute. Just hold on for 1 minute. I'll just be back. Okay, I'm back. You can hear me? You guys can hear me? Just give a Y or N. Okay, got it. So you get basically get an essence of how your distance measure can affect the decision, right? So it always doesn't have to be geographical. It can be in any terms. Now, let's say if you have something like this, if you have a binary outcome, okay. So let's say, is Mumbai metropolitan? Yes or no? And is Pune metropolitan? Metropolitan is some defined as the number of people staying in a city. So if it is greater than some threshold, let's say, I mean, I don't have any idea of how what is the threshold, but I think let's put it as 5 crores. So number of people greater than 5 crores, it's a metropolitan. If it is less than 5 crores, then it is a non-metropolitan. Okay. Now, if I say is Mumbai a metropolitan? Yes, it is a metropolitan. Pune is a metropolitan. No, it is not a metropolitan. And is Delhi a metropolitan? Yes, it is a metropolitan. And then what is the distance measure? You just have yes or no, right? You don't have any number to calculate your distance. So how we do this is basically we, assign 1 if it is matching and 0 if it is not matching. So, for example, if you say that if your Mumbai is a metropolitan, yes, and Delhi is a metropolitan, yes, then the distance between this is basically 0 because it is matching. Okay, so we I mean, if it is matching, we say the distance between, I mean, I would say the similarity is 1 and the distance is 0, right? Because it is matching. And the same concept goes if it is between Mumbai and Pune. So, for example, if Mumbai is yes and Pune is no, then what is the distance between them? It is 1. Okay, so always it will be 1 or 0. It will not be anything other than this. You get this, right? So if it is similar, then the distance between them is 0. I mean, if it is same, that is the only possibility you can have. If Mumbai is a metropolitan and Delhi is a metropolitan, it is yes, and that's why their distance will be 0. If both are not, one is metropolitan and one is not metropolitan, then the distance between them is 1. Now, you would say, when you are saying the distance, it is in kilometers. When you're saying the number of Marathis, this is in percentages, right? And then you're saying yes or no in terms of 1 or 0. How, I mean, these are different numbers. Distance is in kilometers. Number of this is in is a ratio, and then this 1 or 0 is binary. How can you add these distances? Very valid question, right? how can you add this number? So in KNN, the first and foremost thing to do is make your data unitless. If you don't do that, your data unitless, KNN will not make sense. Okay, if for the only time you can go around this is that if you know that all your features have the same unit. For example, if at all everything is in length centimeters, then it is okay to do that. But if you have some length in centimeters, some length in meters, something in percentages, something in yes or no, you have to make your data unitless. How we make your data unitless, we have already seen that last class, right? You can do a max apps scalar, you can do a min max scalar, you can do a thresholding, you can do also do a scaling using uh, the x minus, I mean using the z formula that I'll tell you today. Okay, so how to do your scaling using z formula. So you have to scale your data in if you do a nearest neighbor calculation. Okay, that is the first and foremost thing you should remember when you do a nearest neighbor classification. Okay, I think this is clear to everyone. I'll delete all the drawing. Put this here. Now, after you calculate the distance, this the distance now this is very important. After you calculate your distance, then comes a decision how many distances you should take into consideration. Should you take only the person who is nearest, or should you take an accountability a greater number of people or a greater number of data into consideration and do a majority voting in terms of your fitting? Now, always remember this, get this into your mind, always remember this. Whenever you're averaging out something in your model, okay, for example, I mean, because I'm giving this example because it will help you to understand many models. So always think like this: whenever you're averaging out, okay, averaging out means you're not going particularly on the basis of a single point, you're averaging out, you're seeing what other people also see into consideration, right? So whenever you're averaging out your decision or you're taking a majority voting, you're moving towards what? Can anyone tell? You're moving towards what? Underfitting or overfitting? Write down the answer. Sunil says overfitting. Any other questions? Sharad says underfitting. Vasant under. Krishna Kumar under. Correct. So Sunil, it is not overfitting, it is underfitting because you're considering, as I told you, you don't want your decision to get varied by each of the different points. Huh? You're not, you should not be too much influenced by a single point. That's what we learned, right? When we did overfitting, we were kind of having a graph that is trying to fit every point. This is overfitted, right? But when I'm taking a graph which is kind of averaging out everything near its near wherever it is going, it's kind of a little more underfitted. Okay, so just remember this: when you're kind of taking a majority vote or taking out the average, you're kind of underfitting, moving towards underfitting. Okay, not underfitting. Um, Bear that in mind. Okay, you're moving towards underfitting. And if you're trying to just be influenced by a single, so for example, if your data is like this and you put a KNN with one nearest neighbor, okay, and you try to predict for, let's say, this part, what will be the answer to this? It'll always take this into consideration and have this value. If it is this, it will always take this value. If it is this, it will always take, so it will be very, you know kind of trying to touch every point and not averaging out. However, in this case, it is kind of uh, taking an average and going on its own way a lot smoother. Okay. There's one thing I want to tell you guys. I think that's not in this slide, but I think that's a little important. We need to tell you guys. So there are basically two approaches to model fitting. One is the parametric approach. Okay, parametric, and the other is non-parametric. What do you mean by parametric approach? A parametric model is a model where you have defined the structure of the model. So in case, for example, in linear regression, you already had the structure of the model ready, right? You had y is equal to alpha plus beta 1 x1 plus beta 2 x2. Okay, you had kind of had the structure ready. You just were trying to you were trying to figure out the values of these, right? So you already know that you are going to trying to fit a line, but you just want to know which line is the best one. You guys can hear me, right? There was a little disturbance, I think. Okay, okay. So I'll just repeat again. I'll just repeat again. So there is something called a parametric approach, and there is something called a non-parametric approach. Okay. So parametric approach is wherein you have already decided the structure of the model. Okay. What you mean by structure of the model? For example, when you are trying to fit a linear regression, you already have y is equal to alpha plus beta 1 x1 plus beta 2 x2. So you know that you're going to fit a line, you just don't know which line is the best. You guys understand that? You have already know the structure of the equation in linear regression. You just need to find out what the values of these are. Okay, this is called a parametric approach. Parametric approach, where you know the structure of your model, you just need to find the values of the coefficients. However, there's something called a non-parametric approach. A non-parametric, okay, a non-parametric approach is basically where you don't have any equation. Okay, so in k nearest neighbor, what equation you have? Do you have any equation where you're putting your x and you're getting y? There is no particular equation, right? What your model is trying to do is trying to get your x's, then there's distance measure calculation, and then it is taking a voting or averaging out, and then it is predicting for y. Okay, so it's a process, it's not an equation. So understand it, a non-parametric approach is kind of a process that the model is following in order to predict. A parametric approach is basically an equation that the model is finding the values of. Is this clear, or should I repeat again? I think I'll just open the forum for questions. I'll unmute you guys. Any questions you have on this? Okay, everyone is clear. Can I get an answer, yes or no, so that I can proceed? Okay. So this is very kind of important to know what is parametric and non-parametric. So you'll always may not get the equations. A lot of models that we are going to learn right now is that you'll not get equations out of it. Okay, this is a process. So when you kind of trying to predict there, the model will follow the process and then predict. It will not fit that x into an equation and predict for y. Okay, so understand this. Okay, then I'll move on. Okay, so you have understood this, right? Let's go on. So kind of nearest neighbor is what it is trying to do is it is taking a majority voting. So it is in case it is a categorical variable like we discussed last time. If it is like yes, no, or a duck, swan, hen, chicken, something like that, what it will do, it will take a majority vote. So for example, if k equal to 1, if I see, for example, if it is about colors here, so it will find who is my nearest neighbor. It is brown. It will predict for brown, but then it has overfitted. It is only seeing, it is very, short sighted. It is just seeing brown. But when you see, if you tell, okay, now give me the top three people or top three colors who are closest to you. Okay, so it tells, okay, these are one brown and two green. So then I say, okay, then you're doing a majority vote there basically. Okay, so it will say, yeah, okay, I understand now. So my output should be green. Okay, so it's kind of makes sense to have a majority vote, but then again it doesn't make sense to have a lot of majority vote. Okay, so for example, if I tell, now in this case it is good because it is kind of making a little more sense. But for example, if I say k equal to let's say k equal to how many data points? Assume there are at least 30 data points here. Now if I say k equal to 30 or k equal to 29, what will happen? You're going to predict whichever color is more in your data set. You'll always predict that. You get that? If you say, for example, there are 29 data points, I'm keeping k equal to odd. So if it is because always k should be odd, to make sense out of your majority vote. It can be it can be even if you want to take an average, mathematical average, where we are trying to predict a continuous variable. Okay, but if it is a class that you're going to predict, then it is always advisable to have k equal to an odd number. Okay, because so that you don't end up in a tie when you're trying to predict a majority vote. So I guess this is pretty clear for you guys. Now if k is equal to 29, as I said, if k is equal to the number of data points that you have in your data set, what will happen? You'll always predict whichever data, I mean, whichever color was more in your data set. For example, if you have greater number of browns in your data set, you are always going to predict brown, irrespective of what you choose. And that's not a very good prediction, right? So that's why understanding k is pretty much the most important thing of nearest neighbor. Okay, now we have already seen this. Okay, so a Voronoi diagram, you don't have to be very specific about this diagram, just to make you a little more understand, make you understand a little more about how your nearest neighbor is calculated. So for example, a Voronoi diagram, based on the distances, it particularly creates a boundary. So basically, this is the boundary. Any point which falls in this boundary will be predicted a value of this. Any point which falls into this boundary, it will be predicted a point of this. Because you have one nearest neighbor, right? So it will always be have seeing one neighbor. Okay, any point which falls here. So for example, if you want to predict what is the, let's say, I mean, I don't know what they are predicting here, but let's say you want to predict whether it is a yes or no, whether it's a high, whether it's a male or a female, right? So anyone who has a um, scaled, you see what I told. Every time your Voronoi, even the Voronoi diagram says, every time your dimension should be scaled. Okay, so they have kind of, I think, used max apps scaler. You see everything is I mean, some one point is one and rest everything is one, or they could have used a min max scaler also. So uh, that's what. So if you land up in a data set, let's say someone his uh, scaled height is zero point 0.2 and scaled weight is, let's say, zero point 0.4. So zero point 0.2 and zero point 0.4, you reach somewhere here. Then you see what is the output for this data. This data was your training data, right? This data you already have. So this was probably a male or a female, whatever it is. So we'll always predict that as a female. So everything that comes into this boundary will be predicted the same class as of what this had. Okay, you get these, get this? Yes or no? Any questions? Okay, I think clear. It's very easy. So now, I think we can. So Canadian classifiers are lazy learners. Keep this in mind. It's a very important term. Lazy learners is basically, uh, you know, when you have a point wherein, for example, the testing. I've already told you, since it's a a non-parametric approach, you don't have an equation ready. So it's kind of calculating all the distances. Whenever it sees a new point, it is calculating the distances, it is sorting, and then taking an averaging or majority voting, and then giving you an output. So it is a lazy learner because it always learns when the test data comes. It is not always ready with the equation or the structure. Okay, it always learns as per the data comes. So this is not very. That's why it is not widely used. It is whenever your data is very slow. I mean, it's very big. It becomes very slow, and that's why people don't prefer to use this model. But again, it might give you very good accuracies when you have really cluttered data, and they are concentrated in one part. And that's where in KNN can be very helpful. So classifying unknown records are relatively expensive. That's what. It's very slow. It calculates the distances. Distance calculation is difficult. I mean, computationally expensive. Sorting is again computationally expensive. So it's a very, it doesn't. It's not very scalable, I would say. Now let's look at the code that we have for today. Okay. Now, as per is your request, today I have kind of shown you how your this thing cross validation will look like. So that's why I put this today. Uh, so, for example, I'll start from the beginning. Just follow me here. From sklearn.neighbors, import key neighbors classifier. Basically, the sklearn.neighbors is the package like what we just have a revisit on where how we were doing last time. From sklearn.metrics, sklearn.datasets. Sklearn directly has a linear model, so you need not address anything inside it. But k-neighbors classifier is some in a subset. So from sklearn.neighbors import k-neighbors classifier. From sklearn.model selection import cross-val score. Okay. Now as we go, we'll understand this. So just let's say you have this estimator. So I'm using the iris dataset. I'll show you what the iris dataset is. First of all, load the iris dataset from slm.datasets. Import load iris, import pandaset pd. Do these steps, write these steps if you are writing, and then just do a print x here. So this data set is basically of I'll just you know open this. Let me find the description. So basically, there are some dimensions of the leaves, sorry, the flowers, and based on the sepal length and sepal width and the petal length and the petal width, we're trying to classify whether it is an iris, whether it's a setosa, whether it is versicolor, and whether it's virginica. So just let's see what setosa and versicolor are. Setosa. The setosa is kind of this flower. Okay, if you see virginica, this flower, and versicolor. Oops, it's not versicolor. Anyways, so kind of based on the sepal, I'll also tell you what is sepal definition. So each of the parts of the calyx of a flower enclosing the petals and typically green and leaf-like. So it's kind of a characteristic of a flower, and petal, you guys know. So based on the sepal and petal width and length, I'm kind of trying to predict with that whether that that flower is a setosa, versicolor, or virginica. Okay, you guys understand this, right? So this is basically the iris data set. So for example, these are the dimensions: sepal length, sepal width, petal length, petal width. Now, remember, all these are lengths and are in centimeters, right? So I need not do scaling, as I told you, for this data set particularly. Now, what I've tried to do, I've taken k neighbors classifier is equal to n neighbors equal to 3, and estimator dot fit. I'm fitting the data in x and y. X was what I did. X is iris dot data and y is iris dot target. Okay. So the same thing that we did in last class, right? We took the x out of that the data separately and y separately, and then we fit the model. Similarly, here we fit the model, and then we predict. So let's see what the prediction comes. So I'm just commenting out these lines. So uh, the classes have been labeled as 1, 2, 3. So versicolor, virginica, and that those are 1, 2, 3 respectively. So you fit the model, and then if you try to predict what is the flower for 2, 3, 4, 5. I mean, if your petal sepal length is 2, sepal width is 3, petal length is 4, petal width is 5, the prediction is 2. It means it is versicolor. Okay, so this is how it works. Now comes the interesting part. How do you find the appropriate key? Okay, so let's put all uh, let's see how your cross validation scores will vary with the different odd numbers. Now you can take this to any, you can use your sequence function and start with 1, give your endpoint as let's say 1000 or 1001, and increment those as 2. I'm keeping this short because otherwise the model will take a lot of time to execute. Okay, I mean, even this will take a little more time, so I'll just keep to 17. Okay, now this is a list that you're going to store your each of the CV scores, cross validation scores. Okay, now you start a loop, as I think last time someone told that how do we test the hyperparameters, which is the best. You start a loop for k in neighbors. I mean, for each of the numbers, knn, you say you are saving the model into knn, and this is k neighbors classifier, n neighbors equal to k, scores is equal to cross val score knn dot comma x comma y. Knn is the model that you have saved, x is the data, y is the target. Cross validation, how many cross validations, how many folds you require. If you remember what was k fold in last time, so fold number of folds I require as 10, and scoring is the accuracy metric. We'll come to this later. So can anyone tell me how many elements of scores we'll get here? Write down the answer. How many scores we'll get? Will it be a 1 score, or will it be a 10 score? Will it be 5 scores? How many scores will get here? Okay, so Neil is asking me to repeat the cross validation. Okay, I'll do that. First, can the others answer how many scores we'll get? If you don't know, just write don't know, but give me an answer at least. Okay, so I think we should. Vasan says not sure, but it might be 5. Okay, so I think we should revisit the key fold a little bit more. It's perfectly understood that you might forget, but okay. Now, k-fold is basically cross validation. Now, do you remember? Do you guys remember what was cross validation? So, cross validation is basically that you are dividing your data sets into certain parts. You are using some parts to train your model, and then using the rest of the part to test the model. Okay. Now, there's one there's one concept that you have this data, just divide this into 80-20 ratio, train your model on this, test on this, and let's get over with it. Okay? Why to do so many things for a single data? So I told you, right? I think some of you, I think, answered this question very well. That why you should not just see a particular. I think it was Krishna, as far as I remember. Why you should not see just a single part, because your data could be sorted. So in case of sorted, you would see certain data points, and maybe it is sorted based on the number of based on a number of I mean based on a feature, on the based of ascending order of a feature. So you might see test all of your data on the highest value or the lowest value based on the previous value you've seen. Okay, so you don't want that, right? You want the model to see almost every part of your data. So that's why you do a cross-valid k-fold cross-validation. You use your train. You first divide it into 80/20. Okay, you use your training. You use training to train your model on the 80 part and test on the 20 part. Then you change your parts. Okay, you still have the same ratio of 80/20, but you just shuffle. Okay, you use this part and that part and test on that part. Then you use this part, test on this part. Similarly, so in a 5k equal to 5, what will be the ratio of data splitting? It will be 80/20, right? 4 out of 5 will be used in training and 1 out of 5 will be in testing. If it is k equal to 10, then basically you are using 90% for training and 10% in testing. So k minus 1 divided by k will be used for training and 1 divided by k will be used for testing. This is clear, right? So when I do a k-fold cross validation, there will be k number of scores. So this will, I'll just open this. This will throw up a score. This will throw up a score. This will throw up a score. This will throw up a score, and this will throw up a score. You take the average of it, and then display what is the average score for your particular model. So for example, now don't get confused in k of knn and k of k-fold cross validation. Don't get confused in that. Okay. So for example, for a particular k equal to 1 in k nearest number wala k, you are kind of trying to figure out what is the average score. Okay, then for k equal to 3, you are trying to figure out what is the average score. Then k equal to, okay, let's say number of neighbors. Okay, n, let's keep it as n. Okay, then n equal to 5, you're saying what is the score, but your k is always 5. Huh? Don't get confused. So for each of your n, this process is being followed. For n equal to 1, let me delete this. N equal to 1, you're following, coming here, you're cross validating, and then you're throwing up a score, which is the representative score for n equal to 1. Similarly, then you have n equal to 3, you're running this process, you're coming out with an average score, that is the representative score for n equal to 3. Like this, you have your array. Right? Now understood? Is this a good revision? Okay. So if you know this, then let's try to figure out what we are trying to do. Now you see, I have told my neighbors can be 1, 3, 5, 7, 9, 11, 13, 15, 17, right? Since I'm doing a majority voting, I need to have odd numbers. Okay. Now after you have n neighbors, you want to put CV scores as a list. Okay. We'll see why we want to put that as a list. For k in neighbors, for k in this array, knn is the model where you're storing for this storing this model for k equal to 1 first, and then you're calculating scores. This is a cross validation score for this model on this and x and y. You have k equal to 10 folds, and then you're using accuracy metrics for to score. Now can you tell me how many scores will this have? Can I get an answer? How many scores will this have? Sharad thinks it's just one. That's wrong. Other answers? Come on, guys, give me an answer. It can be wrong. Vasan thinks it's 5. Sunil says it should be 10. Absolutely. Great, Sunil. You are going to have 10 scores. Why? I told you, right? The number of CVs, the number of folds you have in your data, that will be the number of scores you will get. Like here, I showed you, right? You get 1, 2, 3, 4, 5 because k equal to 5. If you have k equal to 10, then there will be another split like this. You will have 10 scores. Okay. So your scores, this score variable, the scores variable will have the score of this, the score of this, the score of this, the score of this, like this. Will have 10 scores. Okay. Accuracy, don't think of what is accuracy. I will discuss that later. But it'll have. Okay. Vasan says, how do you assign CV as 10? As I told you, CV is something which we want to assign depending on the computational power that our machine has. Okay. It can be 5, it can be 8, it can be 10. We discussed that last time, right? It can be anything. It's depending on how much you want to, divide the data, because you see, if you have, I've just used so many numbers, right? 1 to 17. You could have used 1 to 1000 also, right? Now for each of this 1000, you are trying to take 10 iterations. Okay. So it becomes very computationally expensive to do so many things. So it is, you can have 5 or you can have 10. It's up to the user, whatever he wants to. I can put it as 5 here. Okay. That's not a problem. If I put it as 5, I'll have 5 scores. But this is something which the user picks. It's not anything does. It does not relate. It is not related to the model. Don't get confused in modeling and validation. Validation is something to test your model. Now, how to improve that validation? You are using k-fold cross validation. You're not improving the model by using you're not improving the model using CV. Okay, you're just improving your validation process using CV. The test to train ratio data will change. Correct. Perfect, Krishna. So as I told, your test now, it will be 90% training and 10% testing. K minus 1 divided by K is used for training. So if your K is 10, then 10 minus 1 divided by 10, 9 by 10, that's 90%. We can test with any number of folds. Yes, you can test with any number of folds. You can use, but it is usually preferred, to take 5 usually, but you can have any number of folds. That is up to the user. And Krishna, yeah, I was just sorry, I got deflected from the question. So you're saying the ratio will change? Yes, absolutely, the ratio will change. It will be 90% for training. K minus 1 divided by K, that is 0.9, means 90%. And K 1 by K is 1 by 10, that is 10% for uh, testing. So overall, training plus testing should be your data. So this course will have 10 scores. Now I need to, so cv.scores is basically the list that you are storing for each of the number of neighbors. So for example, you are running a loop for k in neighbors. So the first loop is for k equal to 1. You validate it. You have 10 scores. You take the average, scores dot mean. You take the average, and then you append it to the list. Okay, then for k equal to 3, you do the same thing, append it to the list. Now k equal to 5, sorry, n equal to 5, you do the same thing, append it to the list. Now can someone tell me how many scores we will have here? I want a right answer. How many scores we'll have? Just think it through. How many scores we will have in CV scores? 9. Is it 1, 2, 3, 4, 5, 6, 7, 8, 9? Perfect. So number of neighbors you are using, number of, correct, the number of entries in neighbors. That's perfect. So you have CV 9 number of CV scores. You see? Now see how your model behaves. Very interesting. K equal to 1, you're overfitting. Don't use that. K equal to 3, you're going better. K equal to 3, you're going better. K equal to 5, almost same. K equal to 7, better, much better. I think it's still not the best. K equal to 9, somewhat dips. K equal to 11, great, 98%. K equal to 13, I mean, I missed some numbers, I guess. So this is 13. Uh, K equal to 15, it dips. K equal to 17, it dips. So whatever, or which is the best, your K equal to 13 is the best, right? So initially you were overfitting, and then you fit the best, and then you started underfitting. You get this? See how your for your this thing is. So you need not have. So if you have 1,000 scores, you need not see that manually. You just need to have argmax. Argmax is a function. It will return the value whichever. It will return the I mean, you can just do max, not even argmax. If you do the max, then you will come to know the score. If you do know the argmax, then you will come to know which address that max score is available, and accordingly you can find out the score. Okay, so Sunil, I'll explain this how to find out the argmax. Let's take a break of like 2-3 minutes. Just go through this code again. Always, do we need to select the max score? Yes, of course, you need to select the max score because you're trying to see for which K you're getting the maximum score. Okay, so it always you're trying to find the maximum score because you have. But how do we know which K is good? That's how you know, right? You find out the score and then you see which address. For example, if I do an argmax here, so 0, 1, 2, 3. Okay, so it's 0, 1, 2, 3, 4, 5. What is the number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 6, 7, 8, 9, 7. So seventh is the element, right? So again, 1, 2, 3, 4, 5, 6, 7. Seventh is the element. So if you do an argmax here, you'll get 6 as the number, and accordingly, if you print neighbors bracket 6. Sunil, x can be anything. I understand. I mean, sorry, x. Your n neighbors can be anything, but it's not that if you have let's say 1,000 points, you want to take 1,000 neighbors, right? So that's what I'm saying. You can run a loop from 1 to 1,000 and take an argmax of that. So you cannot have infinite k, right? That is not practically possible for you and the machine to find out the best k universally. You have to give the computer a range that find me the best k within this range. Don't ask the computer to find the universal k. It will not be able to find. There are certain limitations you have to understand that exist in computation, right? You cannot tell, the computer can do, but it will take years to find out. If you want to put k 1 to 1 lakh or 1 million or whatever you want to do that, it doesn't make sense even to put so many neighbors. But you have to give a valid range. Normally, it is seen that a k equal to let's say till 25 to 30 is good. After that, it's totally underfitting. Okay, so that's why machine learning is not just science; it's an art. You have to know certain experiences you have to get to understand what is the average k that people use. Normally, k always varies between 5 to 10, 11, something around 15, but not more than that. You cannot put a k of 20, 36, or I mean not 36, k equal to 100 or k equal to 200. It will not make sense. You're badly underfitting the model. Okay, so normally k is between 1 to 30, and based on that, you will find the number of I mean, you can find the best k out of that. Okay, now let's take a break of 3 minutes. Get this into the get this into your I mean, get this very clear, because the cross validation will be using a lot of number of times, and it's just a single hyperparameter. Now there will be models where there are large number of hyperparameters, so just get this thing into your heads very strong, okay? And so that later when we have a large number of hyperparameters, it is easier for you guys to understand. Okay, let's meet in 3 minutes. Okay, I'm back. So, any questions? Any doubts? I'll just put everyone on unmute. And anyone wants to discuss anything?
Hey, could you go up and show us what is X and Y?
Sorry, didn't get you. What?
Okay, I am on in 28, which is okay.
Uh-huh.
Okay, I equal to iris dot data, and how we are getting this?
Where are you seeing? Actually, I'm not. Okay, this one. This one.
Yes, basically load iris.
So
Yeah,
load
these
iris.
5 lines basically
Load,
because
load iris.
that is giving error that there is no X and Y.
No, x is equal to iris dot data and y equal to iris dot target. You have to put. Did you put that?
Yeah, yeah. So, no, these 5 lines were not there on
No.
the screen at the time.
Yeah. So I mean, I went through. So just don't run the code now. Just understand the code,
Yeah,
because the code will anyways be given to you. But yeah, so
yes.
if you have any doubt on this, yeah, that's good that you addressed. I showed this for a brief point of time. That's why. Okay, no problem.
So, timing, could you repeat one more second? What is cross validation score means? After running means what does this mean basically a score?
Okay, so scoring means accuracy. It means when you're
Oh, accuracy, okay.
correct, when you're testing it. So for example, here we are doing a classification problem, right? So we are trying to predict whether which flower it falls into. I mean, which is the flower? It is a versicolor, is it a centosa, is it a virginica? Three color flowers are there, right? So for example, 20% when you are trying to test here, if you see my screen, when you are trying to test here, so let's say there are 20 data points here, right? Out of 20, 18 you got correct and 2 you got wrong. So what's your accuracy? 90%, right?
Okay, okay, got it.
Similarly, you
Yes.
got it, uh, again you have 20, you got 15 of them right, 5 of them wrong. What's your accuracy? 75%. Here you got 17 right, 3 wrong. What's your accuracy? 85%. So when you do a average, you're just taking the average of these percentages. Okay,
Yeah, got it. Thank you.
no problem. I'll ask a question now. What was the scoring in linear regression? Anyone can answer.
Yeah,
Basran?
number of tests that we need to perform.
No. What was the scoring? What were we trying to minimize? What was the scoring in linear regression? What were we trying to minimize and find out the best parameters? RMSE, right? We talked so much about RMSE. RMSE, we were trying to minimize RMSE, right? What? Okay. If you see here on the top, what were we doing last time? What was this? RMSE, right? Root mean square. We were trying to minimize RMSE. Whichever RMSE we are getting the least, see, this is the RMSE for a particular set of. We didn't do which one. I mean, we didn't do a k-fold cross validation there, but that was what our objective was, right? Using regularization, can we decrease the RMSE? Okay, so remember this. Write this down again. Whenever you're doing a regression problem, regression meaning you're trying to predict a continuous variable or a number, in a very simple term, you are trying to reduce your RMSE. Okay, if you are trying to predict for a classification problem, you're trying to maximize the accuracy. Okay, get this very clear, because everything will rotate around this. RMSE is a metric that is being used to be minimized for a continuous number problem. Accuracy is a metric that is going to be used to maximize for a classification problem. Okay, so when, for example, in k nearest neighbor, here we are trying to predict what the flowers. Flowers are classes, so we are using accuracy. Let's say if we were predicting income, then the scoring would have been, in case of accuracy, we would write RMSE, and then each of these scores that we are seeing, this will not be in percentages, it will be in terms of RMSEs. Okay, get this thing very clear. Okay, if this is clear, are we ready to move on to the next model? Okay, then let's go. So I've all seen this. Now we'll do decision trees a little later. Let's see what is logistic regression. Okay, now let's see this. I'll put you guys on unmute, and as I keep on asking the questions, I want some answers. Okay. Now, what were we trying to predict using a linear regression? Was it a classification or was it a regression?
Regression.
Regression. Perfect. A continuous number, right? So we were trying to predict a continuous number. Now, what we used to predict for KNN. I mean, what can we use to predict KNN? Can we use regression? Can we use classification, or we can use both?
Classification.
That's what we used. I am asking what we can use. We can use, not what we used. Can KNN predict regression and classification both, or just one of them single?
Not sure.
Okay.
I think only KNN class.
No. Guys, I just said that KNN can be used for RMSEs. So what I meant is RMSE is for a regression part, right? When I said that when
Yeah.
you're trying to predict a continuous number, when you're trying to predict a classification, you take majority voting. When you're trying to predict for continuous number, then you're taking the average. I said that, right? All these things. So I mean, I think let's draw a very overview uh, tree structure, and then I think it will be a little more clear to you guys. Let's draw one picture here. Let's see. First decision, okay? First decision box, whether it is a regression problem or versus a classification problem. What is a regression problem? I want answers from you. What is a regression problem?
When there is some
Continuous number.
continuous number we have to predict.
Correct. Perfect. This is a continuous number. Okay. What is a classification problem?
When there is some problem, we have to classify in different category basically.
Correct. We have to classify in different types. Okay. So yes, no, or a number. Okay. Now, this is your type of data or type of problem. Let's say not data, type of problem. The next decision is what model you want to fit. Okay. So model. If it is a regression problem, till now, whatever we have seen, what models we can fit for linear regression? I mean, what models we can fit for regression till now, whatever we have seen? A linear regression, right? A lasso regression, right? And a ridge regression, right? You guys get it?
Yes.
Correct. And also we saw KNN today. So KNN can also be used for a regression problem. The next box is what is the scoring. So what the scoring in case of a regression problem is always what? Give me answers. What is the scoring in terms of a regression problem?
RMC.
Perfect. Okay, this is your scoring mechanism, scoring for RMSE. So regression is over. Okay, on the left side was regression. Now let's go to classification. What is the type of models that we can fit for classification till now? What we have seen.
KNN.
Perfect. KNN. Can linear regression be used? Yes or no? Can linear regression be used for classification?
Yeah, should be.
How do you say that?
If we change the category number 1, 2, 3, 4 and put on a regression side.
No, it will not do. That's what I'm saying. You see, I think you should try to understand this first. A classification problem is not a 1, 2, 3, 4. I mean, it doesn't, I can denote it as yes, no, good, bad. It can be true, false, maybe, can't. So anything can be. It is not 1, 2, 3, 4. Regression problem is always for numbers, continuous numbers, which makes sense. 1, 2, 3, 4 means 4 is 4 times than 1. 3 is 3 times than 1. 4 is 2 times than 2. Actual numbers. If I replace male, female to 1 and 2, does it mean female is twice of male? Not, right? There's nothing.
Correct.
You can represent it with anything. It can be 1, 2, 3, it can be 100, 200, 300, anything. But does that mean these are actual numbers? Not, right? Yes or no cannot be actual numbers. So you cannot fit a linear regression problem to a classification problem. It's not just replacing the y with 1, 2, 3. It has to make sense, right? So just get this clear. You cannot fit a particular model which is being used, which is like linear regression, lasso, ridge. You cannot fit it to directly changing the output to yes or no or 1, 2 and fit it, right? Don't confuse this. This is you need to be very clear on this. KNN, yes, KNN can be used for classification and regression, but that doesn't mean that a classification problem is being converted into a regression problem or vice versa. If I have a regression problem, yes, I can use my neighbors, see what their values is. If it is a regression problem, then I take an average. If it is a classification problem, then I take a majority voting. Okay, but don't say that KNN can be used for classification. And it can be used of regression because if I change the classes to 1 2, I can predict it. No, classes and regression classes classification and regression are two completely different problems. A certain model can be used for both the problems, but those models processes are different. KNN's process is different for classification and regression. Okay, no confusion till now. If it is okay, then we'll proceed. If it is not okay, I'll not proceed further because I, there will be a lot of models coming in now. I don't want to confuse you everything. So is this clear to everyone? I want a resounding yes here.
And can you please repeat one more time? Sorry.
The whole thing.
No, just this Canon thing which you are explaining.
Okay. So okay, I'll ask you questions, you answer me so that it becomes very clear to you. Right now, what did we do? We saw the code, right? In KNN, what did we do? What was the iris data set? The iris data set was basically your petal length, petal width, sepal length, and sepal width, right? This was your data set. And using these numbers, you were trying to predict which flower it is. Got it?
Yeah.
Correct. So which flower it means? There were 3 types of flowers. So what is this? This is a classification problem. Okay. So we saw that KNN can be used for a classification problem. Perfect. No problem at all.
Yeah.
Okay.
No.
Now I see.
So one question, basically.
Yeah.
Sorry.
Okay. Sunil, just let me complete this. Otherwise,
Yeah, please.
flow will.
Please go ahead.
Yeah, let me complete this. So after you fit a KNN, now can KNN be used for a regression problem? I say yes, it can be used for a regression problem. How it can be used? For example, here what we were seeing, what does KNN do? It finds out the distance, then sees who are the most closest to me, and then calculates an average. Calculates the majority voting, and say 3 out of 5 are ducks, or 3 out of 5 is virginica. Okay, so I think my test will be virginica. The same way, if I'm doing a regression problem, so each of the neighbors will have a different number. So 100, 150, 120, 125. I'll take the average of these 5 numbers and then get a result. So KNN can be used for regression and classification both. Does that clear a little bit?
Yeah.
Okay. Now, Sunil, you were asking something.
I think I got my answer. It means if we use KNN in our previous example Boston data set,
Yeah.
we will get the price direct. We will get the
Perfect.
price directly.
Yes.
As you told, 100, 200, 300, we will get there.
Yes.
Okay.
Yes. Yes. So KNN can be used in the Boston dataset. Perhaps you can do that as a homework. Try to use KNN for a regression problem. That is the Boston dataset. Okay, that can be your homework. So this is okay now. Now forget all these things. Okay, you have learned everything about modeling till now. Come to cross validation. What were you doing in cross validation? You are trying to calculate the best hyperparameter. Okay, now hyperparameters are fed by the user, so the model needs to take some decision based on something, so that I can tell that this hyperparameter is the best. And that's why you were doing a cross validation to improve, I repeat, to improve the validation process. Okay, this has nothing to do with the model. You are trying to improve your validation process using cross validation, and thus after that you're telling that this is the best hyperparameter. Okay, so I think now it is clear. I want you guys to, if you can just make this decision box like I made it, make it on a rough, and I'll ask you guys tomorrow again some questions, and I want absolutely 100% good, perfect answers tomorrow. How this box will look like. Okay, so I may pick up lasso and ask you what problem it solves. Okay, I may pick up KNN and I'll ask you what problem it solves. Okay, so just keep this ready tomorrow. I'll ask you questions on that. Okay, now let's go ahead. I'll keep the mute button, I mean, unmuted so that you can ask questions as an, because I think it's a little difficult, to write whatever you want to express. So I think anything you want to ask, just ask on and stop me and ask. Okay, don't wait to write. I think it's a little difficult. Just make sure that there's no background noise that comes, so that it doesn't disturb the others. Okay, now what is logistic regression? Don't read all these things. Okay, don't go into what is entropy and all. Logistic regression is basically, now what we saw is linear regression was basically you had a model y equal to a plus bx plus c b1 x1 plus b2 x2 plus something like that. Okay, y was a number. What if I want to have a linear model similarly, but I want to predict a class? Okay, a valid question, right? I want to have a linear model with parameters. I mean, I want to have a parametric approach. What if I want to predict a class? So here comes logistic regression to your help. Logistic regression is basically a linear model, the same thing as a linear regression. The only thing it is trying to do is trying to predict a class and not a number. Logistic regression is ideally suited for predicting binary outcomes. Okay, binary outcome means 1 or
True
0,
or false.
true or false, male, female.
But that's related to classification, right? No?
Yeah, now classification can be multi-class also. Okay, so you can have high, medium, low. You can have 1 to 10 classes also. So classes can be any number of things, as I explained. Okay, so logistic regression is more suited for binary outcomes, but that doesn't mean that it cannot predict a multi-class problem. Okay, clear till now? Correct? Clear till
Yeah.
now? Okay, okay. So, will the bank give a loan or not? Yes or no. Is the email spam or not? Yes or no. Is the transaction fraudulent? Yes or no. Will I clear my? So you get this, right? Get the flavor. So this last line is very important. If we code them the other way around, the coefficients will have the same magnitude but different signs, so it doesn't matter. So I could say, I mean, I give a data set to Sunil and say, I want you to apply logistic regression. He says, okay, no problem. I want to what is the outcome? I say whether my credit, my transaction is fraudulent or not. So he says, okay, no problem. Whatever is fraudulent, I'll say yes as 1, and whatever is fraudulent, not fraudulent, also as 0. I'll give another data set to Sharad and tell him the same problem. He says, okay, no problem. I'll tell whatever fraudulent transaction. I mean, whatever is not a fraudulent transaction, I'll say at 1, and whatever is a fraudulent transaction, I'll say 0. Does that mean Sharad is wrong? No, right? He just coded in a different way. I mean, he just made yes as 0 and no as 1. Sunil said, I want to make yes as 1, 0 as no. It's perfectly all right. Right? There's no particular thing. As I said, that there's no particular order what we are looking for. It's just a representation. So any representation can work. So we'll see how how your signs will change. We'll see that later. Okay, so let's see. We have a we have 60 random customers from a city. We want to know what triggers them to buy a blood pressure machine. Buy equal to 1 means the person bought it, and 0 means the person didn't buy it. Okay. You can as well as have 0 means the person bought it, and 1 means the person didn't buy it. Okay. So it's up to you however you want to code it. Age, we are taking the age as a factor. We may feel age as a part to play in it, and hence we will use it to examine its influence in the buying decision. Now, linear regression, if I come to this, if I try to use linear regression, 0 or 1, is it a continuous value? No, right? I don't have values 0.5, I don't have values 0.2, I don't have values anything between 0.56666. There is no value such that, right? So even if I fit a equation y equal to c naught plus c1a, what will happen? We see here, you'll basically what you'll have, there are certain ages below that people don't buy it, and certain ages below, above which people buy it. Now, if you try to fit a linear regression, you see how the line comes. Does this line make any sense? No, right? Doesn't make any sense.
No.
It's a continuous line. There's just two possible outcomes. You have fit a line which goes from the middle. It's absolutely crap, right? It doesn't make any sense. That's why I was saying you cannot use a linear regression to fight a classification problem. Now you understand why? Okay. Now, what if I can use something like, don't go into the function, see on the right. What if I can make this curve limited to 1 on the top and limited to 0 on the bottom, and it can take any value between 0 to 1. Okay, that is the y part. So based on x, our curve can take any value from 0 to 1, but it will be restricted up to 1, and restricted to 0 at the bottom. So as a mathematician, I would start thinking, okay, what are the functions that we can restrict, that increases with x and goes to a maximum of 1, and decreases with x and goes to a minimum of 0. What can be a function that we can try to make it? So mathematicians think a lot, right? So they came up with this sigmoid function. What it means is basically, don't get too much confused why this function is used. This function, someone has done a lot of research. Okay, someone has done a lot of thinking on what can be a possible function which is continuous between 0 and 1. Okay, and it is restricted to 0 1. So whatever, however high x becomes, it will still be 1. However low x becomes,
So
it will still be yeah, just a second,
I
it
have
will
a
still,
question.
yeah,
Why
just,
are you
yeah. So yeah, depending on any value of x, it is restricted to between 0 and 1. Yeah, your question, please.
Why are you calculating points, point 1, point 2, point 3 for a 0, 1,
Correct. Very good question.
whether the people buy it or not?
Correct.
Okay.
Very good question. I was expecting someone will should ask, and I feel glad someone has asked. So what you essentially do in a classification problem is you set a threshold. Okay. Now it may not be necessary that of what we are trying to do is we are trying to find probabilities. So what is the probability of a person buying a blood pressure machine who has an age greater than 60? Okay, so this value between 0 and 1 is basically a probability, and we'll see how we get that. So it's basically a probability. Now your probability will not always be between 0 and 1. It can take zero point 0.5, zero point 0.6, it can take 0.2, it can take 0.1, it can be anything, right? So what we are trying to model is a probability. Based on the probability, you, me, or cross validation, or anyone who is an expert can tell what should be the threshold. So anything greater than zero point 0.2 should be yes, and anything less than zero point 0.2 should be no. Should it be like this? Or someone can say, no, I think anything greater than zero point 0.4 is yes, anything less than zero point 0.4 is a no. Someone might say, no, I think anything greater than zero point 0.8 is yes, and anything less than zero point 0.8 is no. How do you find a solution to this? Here comes cross validation. Okay, so we'll
Okay.
go
Yeah.
into cross validation later for logistic regression. Why, how we, I mean, for so after KNN, all the models that we'll be dealing with from now will, for classification problem, will give you probabilities. Okay, it will not give you the actual yes or no. So the default threshold that Python has is zero point 0.5, but that doesn't mean that zero point 0.5 is the best threshold for every problem. You need to cross validate to find that best threshold. Okay, so we'll go into sensitivity, you go into specificity, a lot of things are there in classification, how to find the best threshold. We'll go that slowly. Yeah, sorry guys, I think there was a disturbance in the connection. Can you guys hear me now? Okay, just hold on for 1 minute, just a sec. Okay, I'm reconnecting to a different modem, so just bear with me for 1 minute. My connection may go. Just bear with me for 1 minute. Yeah, I think we are back. Sorry for that. So where were we? Yeah. So what we were doing is that what I was studying is that from now, all the models you may see are predicting probabilities and will not give you the exact result. So depending on the cross validation, depending on your expertise, you have to find out the threshold. Okay, we'll see how to find the threshold, but that is a problem of a later stage. Now let's try to understand more on the sigmoid function. Okay, so I think I already have made you understand what this means. So y equal to 1 divided by 1 plus e to the power minus c1 c naught plus c1x. So this part was already there in your linear regression, right? We have changed the structure of this so that y is between 0 to 1, nothing else. This part was already in there in linear regression, but now what we have done is we have changed the structure of the whole thing, and then we are predicting y. So now, if that is the case, okay, now This is basically a background of what is logit function. So logit function is basically, now just forget whatever I've told you now. Think of it as a simple math. If anyone tells what is logit of x, it is log of x upon 1 minus x. Okay? What is sin x? I mean, it's kind of a maths formula. What is sin square x plus cos square x is equal to 1. Similarly, what is the logit of x? It is x log of x upon 1 minus x. That is the function. So logit is a function. Logit function of any parameter is basically log of p upon 1 minus p. Okay. This is just a definition of logit function. Now, remember everything now, whatever I told. So y equal to 1 divided by 1 plus e to the power minus c naught plus c1x. This is what I was seeing, okay, from the previous slides. I told you logit of p is equal to log of p upon minus p. If I apply logit of y, what will be logit of y? Logit of y will be log of y upon 1 minus y. So log of this upon 1 minus this. If you calculate that, logit of y is basically c0 plus c1x, right? So this is of the linear regression form. So what your model is basically, logistic regression model is basically, earlier you were having only y on the left hand side for a linear regression. X, the right side was the same. Now you have logit of y as a function of x. Any doubts till now?
Yeah, I couldn't understand the last part of logit.
Okay.
Logit.
What was the model of?
Explain the terms more.
What was the model used in linear regression? Y equal to linear regression was y equal to a plus beta 1 x1.
B0, yeah.
Yeah,
B1.
correct.
Okay, x1.
I am telling you that to keep y in bounds of 0 and 1, I need to somehow change y so that it becomes between 0 and 1. Okay? So mathematicians have done a lot of research and said that if you take logit of y as a function of x, then your y will always be between 0 and 1. So that's why instead of y, I'm just replacing logit of y so that my values become between 0 and 1. I'm restricting the values of y between 0 and 1. That's a function that I'm introducing. Okay? Little better? Did you understand a little better? I know it's a difficult concept to understand at first. It's not very intuitive. We also had some problems understanding why.
So mainly logit would be used for restriction from 0 to 1 or some value.
Yeah.
Okay.
Yes. So
Thanks. Yeah.
slowly you will get the hang of it. Why we are doing this? But I also agree that initially it is a little difficult to digest why we are suddenly doing this, and you could say why logit. So that's what logit is, a function which is like S of the S form, and this S form is uh, cannot be recreated by any other function. If you can find another function, then that's great. I mean, you could as well do a research paper on that, but there doesn't exist any right now, that which is also simple in representation. So basically this is the part where the logistic regression comes into picture. Now can anyone say, can we use logistic regression for a regression problem per se?
Yes, it's a
Yes.
same continuous numbers,
You're
but
predicting
it's between only some points like
correct,
thresholds.
correct. So it means you cannot use, right? Regression problem is a continuous number which doesn't have any bounds. right? A regression problem should be a problem where as I increase x, my y should be increasing infinitely. If x is infinite and my relation between y and x is directly proportional, my y should also be infinite. It cannot be bounded. So a logistic regression cannot be used for a regression problem. Okay. Okay. Now let's get into the code part. Same dataset, iris, based on the parameters of the petal and the sepal. I'm trying to predict which flower it is, right? Okay. So see from this, from where the cursor begins, from sklearn.linear model import logistic regression. So there's calling of the function. est is equal to logistic regression. We are storing the function here. est.fit, you're fitting the function on x and y. est.score, what is score, I'll explain you. And est.coefficient, est.intercept. Okay, so if I tell guys calculate this, so basically get the coefficient. I mean, let's keep this here. Okay, now here when we did a scoring, this is basically calculating the training score because I've used x and y both. Now let's see if I do the same thing. Okay, no problem. We'll do that later because I have not. Okay. So I think I have not introduced hyperparameters in logistic regression yet. So when I do introduce hyperparameters in logistic regression, we'll see cross validation. But for now, you just remember this. I mean, just see this. EST is the score. So scoring is basically the training accuracy. I mean, x and y you have predicted. You have used x to predict y, and you already had the real y's, and you're just trying to see the accuracy. Same as what we did here, where we were seeing the accuracy here, but here you were seeing the cross validation accuracy. Here you are seeing just the accuracy. Okay, so whatever you have fitted, you're trying to see whether how good. So 96% times you are correct. Okay, and what is the coefficient and what is the intercept? So it's a linear regression problem. Um, just a sec. Okay. So okay. So basically,
Uh,
yeah. Tell me.
I have a question actually. So we saw that you might function error here between
Sorry,
0 or 1.
your voice is
So,
cracking. Just wait. Your voice is cracking. Uh, just a sec. Yeah. Say
okay, nice.
no. I'm not able to hear you. Your voice is cracking. Uh, can you write your question? Can you write your question? Yeah, sigmoid was using 0 or 1, correct? Okay, that's a good question. So how will it solve iris problem? That's a very good question, Sunil. So now let's see. How many flowers were there in iris problem? Can you write your answers on the screen? Guys, can you hear me now? Yeah, you guys can hear me now? Okay, yeah, perfect. Yes, Sunil, ask your question now.
So that was my question. From the sigmoid or rigid function, we will able to predict 0 or 1. Means if that is below 5.5, we'll say no. Above 0.5, it will be 1. But in iris, there is 0, 1, 2. I mean, three classes are there.
Correct. So that's a very good question, Sunil. So as I told you that,
Hello.
hello, 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 hello. Yeah, I'm sorry. I think there's some problem with the connection today. Anyways, yeah. So that's a very good question, Sunil. So I, as I told you, that logistic regression can be used for two classes, for binary classes, but I didn't say that it cannot be used for multiple classes. Okay, so when you're trying to predict, it's called a rest one versus all. So basically, when you're trying to predict a particular flower, you're keeping that as a single class, and the other flowers, for example, if there are three flowers, okay, so when you're trying to predict for one flower, you're ignoring the two flowers. So for example, this is yes, and the other, any other flower is no. Okay, so understand that it is kind of doing a one versus rest problem. Okay, so in a binary it was yes or no, but in this thing what you're trying to do, you are trying to predict a particular flower, let's say, or let's say if there is high, medium, low, you're trying to predict, when you're trying to predict high, then you're ignoring medium and low. Ignoring as in you're keeping them as a different, let's say high is yes and medium low is being clubbed into no. Similarly, when you're predicting for medium,
Okay, but
yeah,
mm, but you need to calculate high, low, medium first, right? Based on the data.
yeah. So that's what I'm saying. So when you're calculating high, you're clubbing medium and low for as in a different. So for example, for a particular data, you're getting the high probability as zero point 0.7, the rest is 0.3. So what you'll say, this is high. Then it will calculate for medium also. Medium probability, let's say it's zero point 0.6 versus the other, which is zero point 0.4. So medium is less than high. And then, for example, in low, you're getting zero point 0.8 versus high and medium as zero point 0.2. So ultimately, you get high as zero point 0.7, medium as zero point 0.6, low as zero point 0.9. So you'll predict point low because low is the high probability. These are not mutually additive. So you saw a problem individually. You first thought, let's keep it high, and let's see what happens if I keep the others two in a single this thing. Then you predicted for medium, and then you predicted for low. So for each data point, you're trying to predict three different predictions, and then you're getting the highest probability out of it. So Iris, I just wanted to give you an example that it can be used for multi-class, but since Sunil asked the question right now, I explained, but I was going to explain this a little later. So when we go into decision trees, after that I was going to explain, because that is there's a difference between decision tree and logistic regression pertaining to this problem, pertaining to this classification difference. Okay. Just give me 2 minutes. I'll be back. Just give me 2 minutes. Yeah, I'm back. So let's say that's a so answering that Sunil's question. So let's see here. You see, okay. How many features does Iris have? Remember how many features you had?
4.
4. Perfect. And how many coefficients you have here? 1, 2, 3,
4.
4 into 3, 3. 12. 12 coefficients you have. You see
Yes.
this? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then you have 3 coefficients as well. So now you understand this. What's your equation? Your equation basically becomes, see this, it's very important here. If you see your equation, so the first y, let's say the flower was, I think it was Virginica. Virginica was the last. Anyways, Sentosa, it was Y Sentosa. Y Sentosa equal to beta 1 into, sorry, x1 into this, plus x2 into this, plus x3 into this, and x4 into this, plus the C part, the constant part is this, right? Similarly, for y virginica, the x1 is this, the x2 is this, the x3 is this, x4 is this, and the coefficient is this. Similarly, for the versicolor, x1 is this, x2 is this, x3 is this, x4 is this. I mean beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4, and the coefficient is this.
No,
So,
no, but we have not given y0, y1, y2 means name we have not given anywhere
no,
in this
no.
example.
So your y target, when
Then
you
how?
when you were seeing a y target, okay. So if you just write,
Yeah, this is a list of all the means 3 flowers in a random way based on the x.
yeah, not random, based on the x. So when you're trying to fit the model, your model very well understands. So it has automatically understood that 0 is one flower, 1 is one flower, 2 is one flower. So basically, it is trying to predict, I mean, trying to find out what is the probability of having this flower, 0. Okay, so that function is basically beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4. So it will
So
calculate.
got it, but why, which flower is 0 basically? That is my question.
So it is automatically done. So what, for example, your data had Sentosa on the first 10, then Virginica on the next 10, and Versicolor on the next 10. So automatically it assigns 0 to the first one, 1 to the first, based on the data it receives. Okay. So if in your data, if your first 10 rows is Virginica, then it will assign 0 to Virginica. If your first 10 rows is Sentosa, it will assign 0 to Sentosa. So as and when the data comes, so Python is reading the data line by line, right? So it reads the first line, it is Virginica. He says, okay, Virginica, let's code it this as 0. Okay. Then comes Virginica, okay, I've already coded this as 0. Then comes Virginica, I've already coded as 0. Then suddenly comes Sentosa, oh, this is not Virginica, now I need to give a new code. That is, then it gives 1. Okay, like this it gives 1 to all the Sentosa, and then as soon as it sees versicolor, it sees, oh, this is a new thing, so I need to code it as 2. Okay, so like this it will. So you see, the data was in that order, and that's why you're 0 0 0, then 1 1 1 1 1, and then 2 2 2 2 2. That's how it is coded. Yeah, your question, I think you have some question. You have any questions, Sunil?
No, sorry, I don't have.
Okay. Okay. So everyone is clear. It might not be clear today. It's a little difficult to understand logistic regression, but is it, let's say, 70% clear? A little bit clear? Okay.
Yeah, we understood the concept.
Okay. Okay. That's great. Sharad says it's not fully. Don't worry, we'll revisit this tomorrow again. Uh, Meanwhile, what I'll do is introduce a little bit of decision trees concept. I'll not go into the actual depth of it, but since we missed around 2-3 minutes due to the connection issues, we'll extend to 9:34 today. So we still have 15 minutes, and we'll see a little bit of decision trees, and so that when you come tomorrow, we can revisit decision trees and logistic regression again. Okay. So in the beginning of the class today, I had told you that sorry. So I told you that there are two approaches. One is parametric approach, where you have a particular structure of the equation, and the other is you have a non-parametric approach, where you don't have any structure, you have a process. Okay. Now, decision tree is a very, very, very simple model to understand. It is like a human brain trying to take decisions. Okay, it's very simple model, very easy to understand. So just bear with me, and we shall get this through very easily. Okay, now let's see. Okay, just make this as a little more interactive. In office or in your work life, how do you take decisions? For example, let's say if you're a marketing manager and you want to take a decision whether to launch this, you have prepared a new product, and or let's say you want to prepare a new product, you want to think whether you want to invest $500 million, or let's say $200 million, or any number, whether you want to invest in its R&D or not. How do you take a decision? Or let's say you are working in Excel.
10 lines and yet.
Correct. Now,
Okay.
if you, for example, if you have a lot of data in Excel, okay, now you go there. Everyone is aware of Excel filters, how Excel filters work. Yes or no? Okay, everyone is aware of. Okay, Excel. I think everyone little bit knows. So basically, you want to see whether you want to launch this product, or you want to make investments on this R&D or not. What do? You ask your subordinate, get me the data. How did we do last time when we took a decision on like this, maybe on a different product, but what were the steps that we followed? So his subordinate tells, oh sir, what we did is we saw the previous data and what we did last time, and based on some parameters we took a decision. So he said, okay, bring me the file, bring me the launch product. I mean, bring me the post launch sales for the product that we launched. So he brings you the file. You see, first of all you check. So for example, last time, or let's say he brings you a lot of database, the whole database of your company, of all the products in post launch, which have been tracked post launch. So let's say you are going to launch a baby powder. First of all, what you see, you do a filter on baby powder. Whatever baby powders have been launched prior to this in your company. So let's say you get around 6 products on baby powder. Okay. Now you want to see, this time I'm launching a product of, let's say, 200 rupees MRP. Go to your Excel, you do a filter on what are the products between 150 to let's say 250. You get, let's say, 3 products. Then you see what was the size of what is the size of your product. Let's say it's 200 grams. Then you search based on your 200 grams, what are the products that was in your database that was between the size of 150 grams to 250 grams. You get a single product. You pick that single product and see the scenario, how it had performed, and you think that this might be replicated for your product. That is the closest you can get. So what did you do? You took a decision based on your previous data, based on some independent decisions made in an hierarchy. First, you saw what is the type of the product. Then you saw what is the price of the product. Then you saw what is the size of the product. A particular hierarchy which At every step shortens your data because you're filtering on that basis. It shortens the data set, and ultimately you get a particular prediction, or you get a particular data which you think it will be the best for your prediction. So this is for how exactly decision trees work. Kind of a human into a human brain, because humans cannot take a lot of decisions. If you say, give me, uh, or let's say in a single step, tell me what is the post launch scenario of 200 grams baby powder which is being sold at 200 rupees. You'll get confused, right? Okay, wait. Let me process this slowly. You want a powder. First of all, let's see what are the powders that have been launched in our company. Then what did you say? Price, right? Price. Okay, let's see what are the price that we have launched between 150 to 250. And then what did you say? Size. Okay, then see what is the size respectively. So you have made a decision based on an hierarchy. You didn't want to do it all together because you get confused. That's how human brain acts. Don't take a lot of decisions together, and then based on that, keep on shortlisting. Or let's say how HR select your candidates, right? How HR shortlists your candidate. There are some companies might get, for opening of two, they might get a pool of, let's say, 5,000 candidates applying for it. How do you even shortlist that? First shortlist. How do you do? Let's get rid of the candidates who don't have the skill set. Okay, so first decision you make on a skill set. Yes, it has. Then you come into the next round. No, it doesn't matter. You just reject them. Okay. Then after the skill set, then you see years of experience. Do they meet our criteria? Yes, they do meet. If they don't, then you reject. Then after that experience, then you see what is the previous salary withdrawn, or what is the expected salary they want. If it is too high than our highest benchmark, you get rid of them. If it is below the benchmark, you take them into further consideration. And then you get, let's say, get down to a top 10 or top 15 candidates, and then you do an interview. That's how it happens. Similarly, decision trees, think of the same as the concept, except for the fact, now this is important, except for the fact that you are trying to predict now. Okay, so now you have, you know divided your data based on some decisions. Now you want to predict. So for example, HR who has been doing this for, let's say, last 10 years. This guy. This some friend of yours, which is your test data. So your HR person has trained on, let's say, it has trained herself or himself for 10 years on a particular data. Now your friend comes to you, which is a test data. He says, hi Sharad, can you please refer me to this HR? I see an opening in your company. This HR, so what do you see? Oh, I know this guy or girl. What he'll do, he'll see first your skill set. Do you have the skill set? Okay, I think you have the skill set. What is the expected salary you're asking? I think you're asking this much. Okay, then it's below the threshold. Then you ask what is the years of experience. He says, yeah, it's around 5 years, I think. And the HR knows that the requirement is above 3 years. I think you can be selected. I am pretty 80% sure that you will be selected, but it will depend on your final round. What did you do? You did your decisions on your test data based on the training set of the HR. The kind of model the HR follows. So based on that, you predicted for your friend. Now, did you get this example? If you didn't get, then I'll go to a simpler example. Did you guys understand? Okay, Sunil, you got it. Sharad, Vasant, what about you? Anything? Did you understand this example? Okay, Vasant got the point. Sharad got it. Great. That's exactly what I wanted for you guys to understand what decision tree is. And I think if you understand that, everything is very easy. For example, let's go to an example what we learned previously. Now, let's say you have your weather outlook, you have the temperature, you have the humidity, and then you want to predict whether children will come out to play or not. Okay, you start taking decisions. You see, you check what is the outlook, whether it is overcast, whether it is sunny. If it is overcast, then children definitely come out to play. If it is sunny, then you check what is the humidity, whether it is low, whether it is high. If it is high, then I'm pretty damn sure that no one comes out to play. If it is low, then I'm pretty damn sure that people come out to play. Got it? So, based on your past data, you have formed this decision. And now, if any day we want to predict whether children will come out to play, what you need to check? You just need to check the outlook. You need to check this whether it is sunny or not, and you want to check the humidity. And based on that, you can anytime you can predict whether they will come out to play or not. Okay, does this make sense? Okay, so we'll not go into the codes today. I think it will be too much. But only thing, can anyone tell me what is the problem in this? I mean, I have not told you this, and I'll be super happy if you can tell this. That, but then I'll not be sad if you don't if you can't answer this. What is the problem is in this? I mean, what is the basic problem in this concept? Can anyone tell me? I'll just unmute you guys. I think you are unmuted. Yeah, I think everyone can speak. Any guess? It's a difficult one, I understand. But any guess?
You mean problem with the data or the
No,
problem itself?
not the data. Problem in the kind of decisions they
Oh,
have made.
decision.
Okay, let me give let me help you here. Suppose you are managing a team of, let's say, 5 people. You give a particular same data set to 5 different people, and you want them to come up with insights. You'll be very surprised that 5 people might come with 5 different insights, or maybe 10 different insights. Why is that so? I mean, you gave the same data, but then why do 5 people have 5 different insights? Why can't they have the same insight? You gave the same data, right?
Hey,
They have
Pradip,
different perspectives.
I, I was on mute basically, so I was telling. So it seems problem is that the hierarchy, I mean priority which we are setting, as
Perfect.
like overcast or sunny, first we have to take, then humidity, then something else.
Perfect. Awesome. Perfect. And I think, uh, was it Vasant before Sunil?
Yeah, I was on mute, so I was saying, but then I see you can't reacting on that
Yeah.
anyway.
Yeah.
So
Yeah.
that is my perspective, and Basant is saying the same. Perspective means for someone, humidity can be the first priority.
Exactly.
For someone, sunny can be the other priority.
Exactly. That is awesome. I think that is really appreciable that you guys have tracked that. So, who told this model to check Outlook first? I mean, for me, I think I don't care whether it is sunny or overcast. I'll first check humidity. Or for me, or for some other guy, it might be like I don't care whether it's humidity or not. He's in Calcutta. Every time it is humid, it doesn't really make sense for him to check the humidity or not. He just checks whether it's sunny or overcast. So that's basically the problem of decision tree. It it takes decision based on a particular hierarchy on which it thinks. Thinks as in there's a particular metric to measure that how important is each of these variables. So we'll go into that tomorrow, but just think like this. Decision tree has a solution to this. No? So someone who had built this, he knew that this will be a problem, right? How to select this hierarchy. The decision tree does have the answer, but it does not address it very effectively. That's where the random forest model will come into picture. So tomorrow we will see decision tree in depth. We will see decision tree codes. We will see the little bit revised logistic regression, and then we'll move on to random forest. Okay.
Okay, it's great. Yeah, it's great.
Okay. Thank you so much, guys. Let's catch up tomorrow again.
Okay.
Yeah.
Okay, same to you. Bye.
Good night.
Good night.